Okay, we come to the next problem. Let G be an arbitrary graph with n nodes and k components. So there is a graph, it could be any graph. So, and what we know that there are n nodes and k components. Okay, if a vertex is removed from G, the number of components in the resultant graph must necessarily lie between, and then we are given these four options and one of them is correct. So we know that there are n nodes. Okay, so there are n nodes in the graph that we know, and there are k components in the graph. Okay, and then we are removing a vertex from the graph. Okay, and then we have to tell that the number of components in the resultant graph must lie in this range. So of all the possible graphs with n nodes and k components, on removing one node from the graph, what is the minimum number of resulting components you can have and the maximum number of resulting components you can have? Okay, so what we know that there are n nodes, and the components in the graph are k. So that is what we know, n nodes and k components, and then we are removing one node from the graph. So we have to find the minimum. Okay, minimum and maximum components. Okay, we have to find minimum and maximum components on removing one node. What's the minimum and maximum components we can have on removing one node? Okay, so let's think about k components. Okay, and then you're removing one node. So suppose you have a graph in which a single vertex, okay, a single vertex like this is itself a component. So this is a vertex, and then you have like your rest of the graph. There is something out here, this is some graph, and this is some other component of the graph, this is some other component. Okay, like this. Okay, so this is one condition. Okay, so this is, you're studying this, and then what you have, this single component in the graph. Okay, so if you will remove this component from this graph, this single component which is a single node. Okay, this is just a single node. So this component is just a single node, and if you remove this from the graph, how many components are you left? You are left with k minus 1 components. Okay, so you cannot go lower than this. Okay, on remove, if you have, because your components will always be less than the number of nodes you have in the graph. Okay, because a component can have many nodes also. So on removing a single node, you are removing one complete component. So that's the minimum you can go. Okay, and then you talk about the other case. Okay, the maximum. Okay, what you want is is you know, you remove one node. Okay, and how many, the maximum number of components you can generate. Okay, by removing one node. Okay, so you remove a node and you generate maximum number of components. How can you do that? Okay, 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 so this is one extreme we just saw, and then we talk about the other extreme. Okay, so think about a situation in which you remove a single node and you are generating as many components as possible. Okay, so this one node must be really crucial, and on removal of that single node, you're disconnecting everything. So think about this graph. Okay, so this is one node, and this is, these are the other nodes that are sort of connected to this graph like this. So think about this example. Okay, and like this. Okay, so this is some graph. Okay, and it has only one component in the beginning, and then you have to remove one node. Okay, so in this case, suppose if you remove this node, okay, if you remove this node, then what will happen? Everything will become disconnected. Okay, so this node is gone and all these other components will be separated. So how many components will be left? N minus 1 components. Okay, so this is the lower extreme, this is the upper extreme. Okay, so no matter what you do, your resultant graph must have the number of components lying between k minus 1 and n minus 1, and that's why your option C is the correct option. Okay, you have to find, you cannot, no matter what you do, you cannot go lower than k minus 1 components, and no matter what you do, you cannot go higher than n minus components, n minus 1 components, and you have to remove just one node. Okay,